Okay, in this video, we're going to look at an application of Le Chatelier's principle to an equilibrium situation. We're going to look at the industrial process that's known now as the Haber process. So let's get a little historical perspective on where the Haber process came from. Nitrogen is a very important element in that it's used to make two things that are important to man: fertilizer for growing crops and making food, and also it's used in making explosives. Almost all conventional explosives are nitrogen-based. In World War I, Germany had their nitrogen supply cut off by the Allies. The nitrogen supply to Germany for a bunch of the world at that time was Chile, the country in South America, which exported a natural source of nitrogen to all over the world. Well, the Allies blockaded Germany and cut off those ships, and so Germany had no way to get nitrogen. So the people there were hungry, and they needed it also for their war effort. So Fritz Haber was a chemist who figured out a viable industrial process to make ammonia, which they could use then to use as fertilizer and also as a raw material to make explosives. This was such a breakthrough that Haber won the Nobel Prize in chemistry for it. However, because Haber also helped win the war effort, and especially in the making of poisonous gas that was used in World War I, there was a lot of controversy over Haber winning the Nobel Prize. However, he is still recognized as a person who made a valuable contribution to mankind. Now, if you're not familiar with ammonia as a fertilizer, here is an image of ammonia tanks. It says on the end here, anhydrous ammonia, meaning it just isn't mixed with water. Mix it with water, you can use it, for example, as a cleaner. This is pure ammonia. These tanks are then pulled behind a tractor that has an implement that injects the ammonia directly into the ground as a fertilizer. All right, so let's look at how the equilibrium and Le Chatelier's principle applies. Here is the reaction that makes ammonia. It's nitrogen gas reacting with 3 moles of hydrogen gas to produce 2 moles of ammonia. This is an entirely gaseous reaction. The problem is that if you just take a vessel of nitrogen and a vessel of hydrogen and put them together, you will get essentially no ammonia from this. It reaches equilibrium very quickly with almost all of the reactant being left and almost no product being produced. All right, so let's consider some things we could do to stress the system and apply Le Chatelier's principle. If we increase the amount of nitrogen in the container, if we just add nitrogen to the container, remember Le Chatelier's principle says that the system will adjust to relieve the stress, or in simple terms, it will try to lower nitrogen back down again. So if we increase the nitrogen amount, the system will shift over here to make more product to get rid of the nitrogen. If we make this go up, the system will shift over here to make it go back down again. It'll make more ammonia. All right, so here is that reaction again. What if we increase the concentration of hydrogen? Okay, think about that for a second. And again, if we increase hydrogen, the system will shift over here to make more ammonia and lower the hydrogen back down again. So if we increase nitrogen, it shifts over here. If we increase hydrogen, it shifts to make more ammonia. So you can say either it shifts to the right, because this is the right side, or it shifts to make more ammonia. Either one of those is fine. All right, so increasing either one of those will make more ammonia. That's a good thing if we're trying to make ammonia. Okay, now what if we were to increase the concentration of this? So when this goes up, the system would then try to lower it back down by shifting over in this direction. Shifting to the left, as we would say, or shift to make more reactant. Okay, remember it's a double-headed arrow, so it can go either direction. So if we're trying to make ammonia, the ammonia itself is not a good thing. If we shift, we make more nitrogen, we put in more nitrogen, we put in more hydrogen, it shifts over here, then the ammonia itself becomes the villain, and we actually need to remove that. So we would be better off to decrease the concentration of ammonia, because that would help this reaction to shift over here and make more. So we increase the nitrogen, we increase the hydrogen, we decrease the ammonia by cooling it and causing it to liquefy and drip on out of the vessel, is basically what we would do with that. All right, we'll in the next video look at what happens if we change the pressure of this system.